if that works. Cool. All right, so quick introduction. What is COES? How do we develop and use COES to develop agents? What we see sort of like general consumer applications, business to consumer applications, and really just overall ability in generating information about how you can use COES. So a little background is I work at ByteDance as a business development and partnerships manager, and I support our COES product globally. Again, I mentioned I am not an engineer, so I want to be transparent about that. If there are specific technical questions or very deep technical questions, we'll likely pass, but I can give you the answers afterwards. So I'm here because I believe that COES gives people an abundant feature, tools that can really help you solve problems, whether it's your own problems for yourself, whether it's for your community, or businesses. And my experience in tech and in partnerships has taught me two very, very important lessons. And that is that no matter where you are in life, you need to be resourceful, and then you have to use everything that is available to you. And if you believe in a solution, service, or product that you're behind, you will always enjoy the work that you do. So straight to what COES is. COES is an AI development platform that offers a friendly environment for people who don't know how to code, who know a little bit of code, or who are full-on developers. So how does it work? Oh, sorry, missed this. So the most features that we have is that you can create an agent with no code. We have knowledge and long-term memory, workflows that if you can get more complex behind that. Scheduling, you can program your agent to initiate tasks before or during conversations, and multi-agent modes. At a very simplistic state, within the platform, you create an agent, and you have the ability to create an app as well. I'm going to skip the apps because that is a little more complex than what I can explain. But then you are prompted to give your agent a name, the function, a persona and prompt, and then you can use the development platform to really give it the intelligence behind it, the intellect. I don't think I have to explain too much about the prompt and persona, but you can give this character a very specific details on how to behave, and what it's expected to do, and also the restrictions. Then you have the section that powers your agent's intellect. COES provides a large suite of models. Hovering over each model gives you the context on what it can be best used for. Each model will also have its own settings where you can choose how you like the model to behave in its output. COES itself also has plugins. So our plugins are a great feature that I think are the most useful part here. These have been created to interact with your databases or other databases to give your agent the ability to retrieve more current information. Therefore, the model that you choose is no longer limited to answering with its trained data only, which obviously, as we all know, can be as far as like 2023, as far back as 2023. So we have a bunch of different features or different plugins that you can utilize to have that feature available for you. Workflows. This allows you to add more complexity on how you like your agent to interact with people. In this specific example, I used the workflow to pick up user sentiment. If it captured the user getting frustrated with the agent's answers, I programmed it to offer having a real human being reach out. And if the user said yes to this offer, the agent will ask the user for its contact information, store it, and then the owner has it available so they can contact them later. There's a lot more complexity that you can build here, and that's really kind of like a playground for all you developers. For me, this is my my favorite feature, the knowledge base. you can upload documents, use URLs to crawl information, connect it to your Google Drive. If you've built an application and have an API that you want to use, you can connect that here, where your agent can get data from and retrieve. Then obviously these agents can natively interact with anything you choose to add, and we'll be able to respond to inquiries on the matter. So overall, we see sort of the most used cases are non-consumer applications, consumer-to-consumer applications, and business to consumer applications. So one, you build your own agent, use it yourself. You can download it on your desktop, do whatever you want to personally, right? Or you can have it built and publish it on different chat applications, as well as use the SDK or API to publish it anywhere. Business to consumer applications, using the API as well. You can publish it using the SDK. Really any digital touch point that you can use. And so one of the areas that we're focusing on personally is like site building applications, where you can easily customize the agent and publish it in this sense, right? So here I used a Squarespace to create a website. I used Coast to develop the agent. So what I did here was I used GPT's basic model. I uploaded a PDF document with information about menu items, modified the agent's UI, and published it on Squarespace website. It's pretty simple in that sense. After you develop your agent and continue to publish it, you can select the code itself, so you don't have to write it. You can basically just copy it, because our platform gives you that code to copy and paste it to any place of your choice. And in this case, Squarespace site was very easily to publish and change, and that's how it came out. There's a lot of customization options within Coast, and that is the sort of easiness of the platform that you can build on. That is my time. Yeah, all I want to say is that Coast itself has a lot of features that can be very beneficial. You can use it for creating your own business, whatever that you find needed. And yeah, thank you for your time. Let me see now how you.
Yeah, thank you, Molly. Thank you. It's very inspiring talk. And also, like, do you want to tell the audience the Coast account, I think there were some, I think for the first for the registered user, they will have some free credit, right? Free to try agents.
Yeah, so I think we're gonna have some time at the end of all the presentations for doing like a hands-on workshop. And if you go to coast.com, you can create an account, and you can do like a 3-day free trial, or you can have a free account and you have limited usage. But yeah, I mean, we wanted to give you kind of a hands-on experience on that specific space. And if you have any questions, we'll be here to go through it. But if you want to go ahead and create an account, coast.com is the platform itself.
Cool, thank you. Okay,
Yes.
so yeah, any questions?
Any questions?
Okay, so let's continue then. Tina, are you there? Tina, can you hear us?
Tina is not here in this building yet. I don't know if she's connected.
Yeah, she's connected, so I think probably, yeah, give Tina a few more minutes. I think the next, I think Alex, is Alex there? Hi, Alex.
Yep. All right, we're gonna disconnect and he's gonna connect.
Yeah. Okay, cool. So next one, I think the next talk is from Alex Liu. I think Alex Liu. Hey, Alex. Yeah. Okay, cool. So let me give the audience some short introduction about you. I think. Oh, I heard you're a legend. Like like your company is acquired by Meta. Is that something that you want to tell everyone? Hi, Alex.
Yes, yeah. Can you hear me now?
Yeah, we can hear you. Yeah, yes. Back to you now.
Oh, yeah, I heard your question. So unfortunately, we cannot comment that right now.
Okay, sorry.
So you may see some news later on.
Yeah, so it's a rumor. It's a rumor. I heard the rumor, but now you can start now.
Yeah, we cannot deny it or prove it.
Okay.
Yeah. So let me share my screen. Okay, can you see my screen now? Is that a full screen?
I didn't see your screen. Can you share it again?
Okay.
Oh, yes, I saw something.
Okay.
All right, cool. You can start. Thank you.
Good. Yeah. So let me introduce myself first. So my name is Alex Liu. I'm the SVP in InfiniEdge AI. So I'm responsible for the global product management and business. And the Future AI is an AI accelerator startup based in Seoul, South Korea. So we have been in this industry a few years, and we have designed two generations of the products. The first generation is focused on the video models, and the second generation is kind of, we call it the Renegade. It's kind of NVIDIA H100 class of the AI accelerator. And also in this generation product, we create a very unique architecture we call the tensor contraction processor architecture. So later on, our main topic will focus on this new architect. And I can proudly to say that currently we are the #1 of the Llama inference AI chip regarding the performance and performance to power ratio. And we are developing other AI models as well right now. So let's back to the original. So why we created this company and why we created this new architect. In fact, there are a lot of the challenges that along the way when we develop new AI applications or technologies. So especially if start from this year, 2025. So with the new foundation models like DeepSeek, right, or other applications like RAG, or we just talked about the multi-agent workflow applications as well, right? It's a very clear signal that this year is the starting point of the AI inference. And in fact, many people projection difference of the training versus the inference, the growth rate. And many people even claim, oh, that may be 100x of small regarding the increase. But with the technology improvement, is that our infrastructure ready? So there's a chart, I'm not sure you can see that clearly or not. So if we look into the data centers right now, most of the data, most of the racks with very power supply right now, majority of that is less than 10 kilowatts. That for the premium ones, like larger than 20 kilowatts or even larger, that's only a small portion of that. So what's the problem? So think about you spend a lot of money to buy a full system from NVIDIA, but you don't have the power to plug in. You don't have the cooling solutions to solve that issue. In fact, that is a big issue for the industry. That's why there are a lot of people talking about building new nuclear power plants or something, right? But again, that takes years, and you also have a lot of other challenges. So that's one, the power. And the second one is we've already seen many generations of the AI hardware, right, regarding the GPU from NVIDIA, AMD, also Intel, of course, like the body. But there's always a challenge that they are optimized for current generation of the AI models. But what about the future, right? So once there are new AI models come up, you always have to refresh the hardware, and it's quite a big spending. And a lot of companies, in fact, they couldn't build a successful business case for that. They spend all the money to training the model, then you have to refresh again, right? Restart again. So that's the graph I mentioned. There's need a new kind of the AI processor that can not only optimize for current model, but also flexible enough for the future AI models. So, and of course, you need the performance to provide enough satisfaction to the end users. So it seems impossible triangle that you need to solve, right? Programmability for the flexibility and the superior performance, and also the low power that you can deploy into not only like the premium data centers like you have, but for a lot of small data centers or enterprise that they have very limited power. A small data center they can fit in, then you need some optimized design for that. So we believe we have solution right now. So this is our product, the second generation called the Renegade. It can have the H100 class of the performance, but if you check the power numbers, when it run the full performance, it's only consume about 180 watts. That can compare to the others is just a small portion, right? And with that, the power you can put into the traditional air-cooled data centers, or put into a hard rack anywhere that as long as you have space, and you only consume that kind of watts. If you consider with the 8 cars server that only consume less than maybe 2,500 watts, that's nothing right now, right? And also in this generation product, we put the 48 gig of the HBM3 memory, and also have 256 mega of SRAM. It's quite a premium design as well. So regarding the performance for the Llama 70B, each card we can achieve 1,000 tokens per second. So that's the performance and also the hardware spec. So what is the secret sauce? In fact, that's the main topic that we have. We built the product in a new architecture called the tensor contraction processor. In fact, tensor contraction is a generalization of the multidimensional tensor reduced dimension way, right? It's starting to get famous after the Albert Einstein read his famous paper. Right? And right now, the tensor contraction, in fact, is the major workload, no matter in the physics, AI, and also quantum computing. The base is the tensor contraction. So we built this chip, right, general enough to support all the tensor contraction operations, but also have some specialized design to make it more suitable for the parallelism and also the AI acceleration. In that we can enhance both the efficiency and also the performance. And here is some data, right? If you talk about the latest the transformer architect of the AI models, using BERT as an example would be enough, and also many people already studied that. In fact, 99.7% of their flops is used for the tensor contraction. And this is on the left side of the highlighted blue ones. That is the tensor contraction operation. And we designed this chip to optimize all these operations and to improve the data reuse and to reduce the data movements. And the data movements, in fact, is the most heavy power consumption part compared to the PE or the computing part. For example, if you calculated the power consumption that moving data from the DRAM to the PE and versus the PE to run the computing part, the moving data is consumed 10,000 x of the power consumption compared to the computing. So whatever the latest or the newest design is, all focus on how to reduce the power movements or the memory walk in copy. And in the tensor contraction, so tensor contraction, you can see that is a higher dimension of the generalization of the matrix multiplication. So it is kind of the declarative instead of like the traditional way of the GPU or the other NPU they are doing that they need to do the explicit memory layout and also the explicit scheduling. What that means, that's also create the issue of the so-called CUDA mode, right? Because it's so difficult to utilize the hardware efficiently. So you need a lot of special knowledge, right, to do that. That's not so easy. But you use this new way of the tensor contraction way that if we are focused on the declarative way of you just need to say what you want to do, but the hardware, the compiler itself will find the best way to execute that. So that gave the freedom to the designers or the AI engineers to focus on their innovation instead of the tiny details and struggling every day. And using the upper part, that's the traditional of the matrix application. And we are using the so-called handstand summation and notation method. So that is the way we just all follow the same very elegant way to handle all the AI workloads. And because of we are using the declarative way, that means that there can be numerous ways of to compute the same output. So our compiler can see the whole model graph as a whole and find the optimization ways of how to reuse the data, spatial-wise or temporal-wise. In that case, we can maximize the optimization opportunities and save the power. So this is the example. Because we have so low power, we can put 8 of our cards into a very typical server that only consumes, like I said, 2,500 watts. And this server can form, if you're talking about Llama 70B, which is a traditional, a mainstream large model, you can output 8,000 tokens per second. So what that means? So if you have a small data center or you have a small enterprise server that serves your company, with that one server, and you can allocate it to 80 to 180 users use that simultaneously. And each user can have the 50 to 100 tokens per second of the output, which is much sufficient, right? So that means you only need to spend a small portion of your IT budget, then you can upgrade all your AI infrastructure easily. And on the right side, we compared our performance to power ratio compared to H100 and also L40, which is also mainstream NVIDIA device right now. You can see that both in the 8 billion model and the 70 billion model, we are far more better than them. And this is just the beginning. So there's a lot of the optimization still ongoing. And that's one of the things I want to mention as well. So the tensor contraction processor architecture is so elegant. It gave us the power like a startup compared to NVIDIA. We are quite tiny, right? Only have less than 200 people right now. But in the past few months, our performance or optimization, the achievement already surpassed NVIDIA in the past 2.5 years. And they have tens of thousands engineers. So that's why you need the innovation on the architect side, then give you all the power to grow. So this is on the single server part. So if we think about a little bit larger, right? In the real use case, you have an empty rack that already have the 15K kilowatts of the power supply. So you can easily deploy 6 of our servers into that rack. You have enough space to put into like the routers or other components. But for the NVIDIA, that you can only put one of the H100 systems. So if you can compare the performance, that we are more than 3x of the H100 system. So that's really the business benefits to all the AI application developers or the companies. On the hardware, that we talk about a lot of the hardware side. On the software side, we have the very important design philosophy is the software and hardware co-design. So from the chip architect design to the whole pipeline, we or software and hardware co-design all together. So that we have a full stack of the software and on the large language model server service part, we also have a full stack software that once you have any model that we can easily to convert to run that on our hardware. So on the open source side or other ecosystem side, also compatible with the PyTorch 2.0. That on the front end, on the back end, we are also working with Triton. So that means there's whatever you are developing AI model right now. So there are very large chance that we can easily to adapt to that. So due to the time-wise, I didn't give too much details about that. So here's my LinkedIn profile. You can scan it and we can connect. And if you have interest, I can share you a lot of the good papers or blogs. And we can also have some online API that we can provide later on that can help you to understand how it is used. On the API side, for example, we have the fully OpenAI compatible structure right now. Okay, that's conclude on my presentation. Thank you. Any questions? Okay. Yeah.
Thank you, Alex. And Tina, are you there?
Yes.
Okay, so back to you, Tina.
Sorry, we have one question. Oh, okay, we can talk.
Yeah.
Oh,
Okay.
that's fine. We will talk offline. Thank you.
Thank you. Okay, Tina, back to you. Tina, can you hear us? You're muted. Let's wait like a few minutes. I think Tina, she's adjusting her devices probably. Okay. Cool. Tina, I can't hear you. I can only see your desktop.
Yeah, I think we can see your sharing, but you're on mute, so we cannot hear you.
You still didn't hear. Tina, can you hear us? We didn't, we can't hear you.
Hello?
Yeah, we can hear you now.
Oh,
It's working now.
this is the microphone? Hello?
This is yours, right?
It's working now.
Yeah.
Thank you.
Where's the
Oh,
output?
okay. How about now?
Yeah. It
Okay.
works perfect.
Yeah, let's begin with an overview of what release 1.1 brings to InfiniEdge AI. This release is packed with enhancement and new functionalities that elevate our Edge AI platform to the next level. We concentrated our improvements on the three key areas: performance, usability, and integration. In terms of performance, InfiniEdge AI 1.1 is optimized to run AI workloads faster and more efficiently on edge devices, meaning quicker inference times and lower latency for real-time applications. On the usability front, we've refined the user experience to make the platform more intuitive and developer-friendly. So it's easier to deploy and manage AI on the edge, at the edge. And for integration, we've expanded how InfiniEdge AI connects with other components and systems in the ecosystem, enabling more seamless data flow and interoperability. In short, Release 1.1 empowers more efficient edge AI processing. You will notice snappier response times and smoother connectivity with both cloud and edge components. This overview sets the stage, and next we'll unpack these areas in detail. Now, let's talk about the new features and improvements in Release 1.1, one by one. First, performance enhancements. We've turned the AI inference engine under the hood, so models run faster and more efficiently. For example, with our updated engine and the new AI processor, we'll experience noticeable lower latency. Edge devices can process data in real time or near real time. This means tasks like image recognition or sensor analysis happened quicker than before, which is crucial for time-sensitive applications. We've also improved throughput, so the system can handle more AI tasks concurrently without bogging down. Next, usability improvements. User experience has been a big focus in OneNote. We know that deploying AI to the edge can be complex. So we've overhauled parts of the interface to be more intuitive. Expect a cleaner dashboard and more guided setup for common tasks. For developers, we've streamlined workflows from importing models, configuring edge nodes, to monitoring performance. The deployment and configuration steps have been simplified, reducing the learning curve. In short, we want both new and experienced users to navigate InfiniEdge AI more easily. Lastly, integration updates. InfiniEdge AI 1.1 plays nicer with other systems now. We've tightly integrated our Sphere workstream with the OPEA platform. More on that shortly, to create a comprehensive ecosystem. This integration means data and commands can flow smoothly between InfiniEdge and enterprise AI services provided by OPEA. Additionally, we've added and improved APIs and connectors. So if you are using InfiniEdge AI alongside cloud services or other edge framework, you will find it more plug and play. Essentially, release 1.1 ensures InfiniEdge AI can slot into your existing workflows with minimal fuss, bringing edge and cloud components more effectively. Let's delve into one of the most exciting aspects of release 1.1, the integration of Sphere and with OPEA. First, some context. Sphere is a component or workstream within InfiniEdge AI that focuses on edge processing and real-time analytics. You can think of a Sphere as the sharp end of our edge computing capabilities, handling tasks at the device or edge node level with high efficiency. In this release, we've significantly extended what Sphere can do, and importantly, how it connects to the rest of the ecosystem. On the other side, OPEA stands for Open Platform for Enterprise AI. It's an open source cloud-native platform that provides a suite of AI tools and building blocks for enterprise applications. OPEA is designed to be flexible and composable, meaning you can plug together various AI components, whether it's large language models, data stores, or pipelines, in a standardized way. It works across different environments, cloud, data center, edge, and emphasizes enterprise requirements like trust, stability, and scalability. Essentially, OPEA is a broad platform that many organizations can use to develop and deploy AI solutions at scale. Now, what did we do in InfiniEdge AI 1? We achieved a deep integrations of Sphere with OPEA project. This means our edge-focused Sphere model can now communicate and operate within OPEA's framework. Concretely, you can take advantage of OPEA's powerful AI pipelines and apply them directly at the edge via InfiniEdge's Sphere. In this release, we demonstrate a one-click DeepSeek exploration using OPEA. Basically, a complex data analysis workflow can be launched with a single command, leverage OPEA's orchestration while running on InfiniEdge AI's edge infrastructure. This dramatically simplifies deploying advanced AI workflows. What used to require manual setup across systems is now almost a push button. The benefits of this integration are huge. We get seamless interoperability between edge and enterprise AI systems. Data collected on the edge by InfiniEdge AI can flow into OPEA's pipelines, and results or models from OPEA can be deployed back to the edge via InfiniEdge AI without friction. Because OPEA is built to integrate with enterprise software and supports heterogeneous environments, InfiniEdge AI inherits those strengths. In practical terms, InfiniEdge AI can now run in many places it couldn't before, because OPEA's architecture allows it to run everywhere from cloud to edge with stability. Users benefit by getting the low latency offline capabilities of InfiniEdge at the edge, together with the scalability and governance of a cloud platform like OPEA. It's truly the best of both worlds. The agility and the speed of edge computing combined with the power and oversight of enterprise AI platform. This integration is a major step toward a unified edge to cloud AI ecosystem. Next, I want to highlight the AI agent platform and summarize the demonstration we have prepared. InfiniEdge AI's architecture in release 1.1 is built around the concept of AI agents. Think of this as intelligent services or modules that run either on edge devices or coordinating between edge and cloud. The AI agent platform is essentially the layer that manages these agents. Its capabilities include deploying AI models to edge nodes, managing their lifecycle, handling data flow between the agents, and make real-time decisions. For example, you might have one agent that pre-processes sensor data on an IoT device, another agent that runs neural network interface on the pre-processed data, and perhaps an agent that aggregates results or sends alerts. The platform allows all those pieces to work together seamlessly. From an architecture standpoint, the platform is modular and scalable. This means you can add or remove agents as needed for your application, and the system scales from one device to many. In our design, multiple agents can coordinate. They communicate through InfiniEdge's messaging or event system, passing data and triggers to each other. One highlight is that these agents leverage the integrations we discussed. For example, an agent at the edge case the Sphere component for efficient on-device computation, while another agent might interface with the OPEA cloud services for tasks that require heavier processing or access to large models. The ending result is a flexible pipeline. Data comes in, an edge agent processes it, maybe sends some summary to a cloud agent for a bigger analysis. And then the results come back to the edge. All of this is orchestrated by the AI agent platform. We built it to handle real-time requirements. So even as data streams continuously, the agents respond and adjust. During this session, we have a live demonstration of the AI agent platform, I hope, right? In the actual presentation, this demo runs for about 10 minutes, where we walk through a specific use case. While I can't show the live demo in this slide, I will describe what it entails. In the demo scenario, imagine we have a network of cameras, edge devices, monitoring an environment. The demo shows an agent on each camera doing on-the-fly object detection using an AI model at the edge. Those results are then sent to a central agent that aggregate the data to detect the broader patterns, like tracking an object moving across camera views. The demonstration highlights how the platform deploys the model to all cameras, how each of the camera's agent works independently. Quickly, thanks to edge processing, and how a coordinating agent can gather insights from all of them. We also show the systems interface where we can watch agents being deployed, see their status, and monitor their outputs in real time. This really emphasizes the power of InfiniEdge AI 1.1's agent-based approach. It's handling complex distributed AI tasks smoothly, which is a key for IoT and apps. The takeaway is that our AI agent platform makes it straightforward to orchestrate AI across many edge devices, and we've proven that through this demo. Let's talk about what's under the hood. The AI processor advancement in this release. InfiniEdge AI 1.1 comes with a new AI processing unit integrated into the platform. When we say AI processor, this can refer to specialized hardware or a highly optimized software component for computation. In our case, it's actually both. We support a new generation of Edge AI accelerator hardware, and we've turned our software to fully exploit it. This is a many-core AI accelerator that's really good at running machine learning models efficiently. If you recall, InfiniEdge's InfiniEdge's mission is to push AI to run directly on devices, and having the right processor is key to that. In release 1.1, with this upgraded processing capability, we can run sophisticated AI models faster than before on edge nodes. What does this mean in terms of performance? In practical terms, we'll see a notable performance boost. Neural network inferences, whether it's image classification, voice recognition, or anomaly detection, execute much faster how compared to version 1.0. We've measured this in our labs. Depending on the task, you may see speed-ups that make previously sluggish tasks run in real time. For example, if an image analysis took 200 milliseconds before, it might now take just 100 milliseconds. That's a hypothetical example, but it gives an idea of the scale of improvement. This lower latency is crucial for scenarios like autonomous systems or interactive applications where every millisecond counts. Also, improve the throughput means an edge gateway device to handle more camera feeds or sensor streams in parallel than it could before. All this contributes directly to better performance in the field. Now, just as important are efficiency gains. Edge devices often have limited power and cooling. Think of a drone running on a battery or a sensor unit out in the field. Our new AI processor is optimized for low power usage. It's doing more computation per watt of energy than before. That means you can run intense AI tasks without draining your battery immediately and without overheating the device. This is huge for edge deployment because it extends the operational life of devices and avoids the need for heavy-duty cooling or frequent recharges. Essentially, you get cloud-like performance on a tiny device but still operate within the edge's constraints. The impact of this processor advancements is that we can now deploy more complex and powerful AI models at the edge. Things that previously had to be sent to the cloud for processing can now be done on-site. For example, consider a scenario in healthcare. Analyzing medical images with a large deep learning model. With a stronger edge AI processor, you might run those analyses in a hospital in real time instead of sending data to a distant server. Or in an industry setting, a heavy predictive model for equipment failure can run on an on-premise edge server right on the factory floor. This reduces dependence on constrained internet connectivity and also alleviated cloud server load. In sum, the new AI processor in InfiniEdge AI 1.1 dramatically broadens the scope of what's possible on the edge. Faster responses, more autonomy, and greater efficiency. It's a foundational improvement that benefits nearly every aspect of the platform. Now, theory is great, but we learn best by doing. That's why InfiniEdge AI Release 1.1 comes with a hands-on coding session. This is essentially an interactive workshop or collab designed to let you try out the new features in a guided environment. Let me give you an overview of how this session works and what you can expect from it. The coding session is structured as a step-by-step interactive collab. You will start from scratch or a template project and progressively build a small edge AI application that takes advantage of Release 1.1 features. It's not just a demo you watch, you will be coding along, either on your own laptop or a provided environment. For instance, one of the exercises might be to set up an AI agent on the edge node and connect it to the OPEA backend. Another exercise could involve using the new processor acceleration. You might run a benchmark with and without the acceleration to see the difference in performance. The session will cover key aspects we discussed today, but in practice, setting up the Sphere and OPEA integration, deploying an AI agent, and utilizing the new APIs and tools. During the live coding exercise, you won't be alone. It's guided. There's a script or instructor leading the process, and you will have a real-time support from our team of experts. The format is very much learn by doing. For example, we might say, now, step 3, deploy your models to an edge device using InfiniEdge CLI. As you do that, if an issue comes up or if something isn't clear, instructors, either in person or via the chat, depending on the format, right there to help. We expect participants to ask questions like, oh, what does this configuration parameter do? Or I got an error at this step, how do I fix it? And we are ready to assist on the spot. This interactive element ensures that no one gets stuck for long and that everyone can follow along successfully. The goal of the hands-on session is to reinforce what you've learned from this presentation in a concrete way. By actually using InfiniEdge AI 1.1 yourself, you will gain practical experience. You will see with your own eyes how the Sphere and OPEA integration is configured, how an AI agent is deployed and monitored, and how the new processor speeds things up. There's something powerful about that aha moment when you run a task and notice it's twice as fast. We did it Tuesday on Stanford University. It worked. Or when you see data flowing from an edge simulator through OPS pipeline seamlessly. Those moments make the features real and not just slides on the screen. By the end of the session, our hope is that you feel comfortable with the basics of InfiniEdge AI 1.1, and you are inspired to take what you built in the workshop and expand on it or apply it to your own use case. We encourage everyone to participate in this coding lab if possible, because it truly cements the knowledge and makes the learning stick. As we come to a close for my presentation, let's recap what InfiniEdge AI Release 1.1 offers and outline what's coming next. In this release, we saw a strong emphasis on performance, usability, and integration. The improvements we discussed, from the new AI processor to the refined agent platform and the Sphere OPEA integration, collectively mean that InfiniEdge AI is faster, easier to use, and more connected than ever. If I were to sum it up, InfiniEdge AI 1.1 makes deploying AI at the edge more powerful and more seamless. The impact of this enhancement is significant. You, as developers or practitioners, can undertake more ambitious edge AI projects. You can run complex models on site in real time with less dependency on cloud connectivity. And because of the integration work, InfiniEdge AI can slot into your existing enterprise AI pipelines or workflows without a hitch. This lowers the barrier for organizations to adopt edge AI. It can be an extension of what they are already doing in AI rather than a separate silo. Looking forward, I want to highlight this is an ongoing journey. Release 1.1 is a big milestone, but we are already working on the next set of features. Some upcoming developments on our roadmap include further integration phases and new capabilities. For instance, we are exploring federated learning features so multiple edge devices can learn from data collectively without centralizing it, enhancing privacy and efficiency. We are also looking at more advanced behaviors for AI agents, perhaps enabling them to learn or adapt on the fly at the edge. And of course, supporting a wider range of edge hardware is on our list. So you can run InfiniEdge AI on anything from powerful servers to tiny microcontrollers. Basically, expect continuous innovation. We plan to keep rolling out enhanced features, and we are actively seeking collaborative initiatives with partners and the open source community. InfiniEdge AI is part of the Edge family, and we strive on community input. So one of the next steps is please get involved, whether by trying out the release, reporting issues, contributing code, or just giving feedback on what you need most at Edge. In terms of immediate next steps for you, the InfiniEdge AI 1.1 release is available starting today. You can access the code and documentation on our GitHub and website. I encourage you to set up a small test, maybe replicate what we did in the hands-on session, or apply it to a problem you care about. We will also be hosting a community call next week, especially specifically to discuss experiences with 1.1 and gather feedback. So look out for that invite if you're interested. And for those of you here at the workshop, since this presentation is part of our collab event, The next step is to jump into the Q&A and discussion right now. Lastly, a big thank you for your time, attention, and engagement. It's been a pleasure to share what's new in InfiniEdge AI 1.1 with you. We are excited about the direction we are heading, and we hope you are too. Let's continue the conversation. I'm happy to take any questions you have or hear your thoughts on the release. Thank you. Now I open the floor for Q&A. Okay, I stopped the students and teachers. Okay, yeah, it's okay if you don't have questions right now. We can sort of yeah, question, please.
Can I actually coding lab? If you mentioned on the data, where on
The data?
no, the coding lab.
The coding lab is right here after we finish the presentation. We have coding lab here.
What you mentioned.
Yeah, right. For the presentation. Yeah. Okay. Now let's move to Noe Otero, who will demonstrate the exciting new capability of AI agent.
No, he already presented his talk.
Sorry, I'm the only person running late on the previous meeting. Thank you, Noe and Alex. You already presented.
So let's continue to the next event.
Yeah. So next, what presentation from about the detailed exploration of Sphere, its role within system, technical innovations, and its integration with OPEA project. The floor is
Thank you, Tina, for the sharing. So next will be a drawing session for what the title that Tina wrote. So let me share my screen. Yeah, next is the drawing session for us to have the Infinite AI Sphere and OPA integration. So we have two speakers. First one is Wilson Wang from ByteDance and Mei Wu from Intel. So I think there will be like two parts. We will have some introduction of Sphere, next introduction for OPA, and then we will talk the detailed plans on how Sphere integrates with OPA. So let me first hand over to Wilson for the Sphere introduction.
Thank you. Hi guys. I'm Wilson Wang. I'm from ByteDance, and currently I'm working in the BG team, which is ByteDance Global Edge, and we actually actively investigating how to run AI workloads in our edge environment. So today I'm just going to present this like the Sphere project, which is under Linux Foundation InfiniEdge AI. It's one of the work stream in InfiniEdge AI, and its main focus is a scalable and distributed AI agent platform. So let's look at this burger. And on the top we have the developer and users, like for the AI, using AI. And at the bottom we have the computing power, but there is a gap between the users, developer, and the actual computer power, because they cannot use these computer power directly. So instead we need something in between, right? So that's why we have this burger. And there are, well, maybe one beef patty is not enough for you, so we need at least like two of them to make you feel full, right? And here in my case, I put the AI agent and model serving. So model serving is something very close to computing power, but for the users, actually most of them are not really care about what kind of model they are using. So they only care, what the AIs can do for them, right? So that's why we need AI agents. So AI agents stand between the developer users and the model serving. So the AI agents use the AI models, and do something real. For example, booking the tickets for you or plan your trip to somewhere, right? So that's why I show the AI orchestrated stack. So we believe that before we actually using the computing power and the models, we need AI agents. Okay, so now let's look at these pain points. And the pain points like here in that stack, they are like, for example, for computing power, we need to support heterogeneous hardware. For model serving, we need to use, make best use of all the computer powers. And there are another two main categories of the pain points. One is AI agents, which we need to run AI agents faster, and we need to run lighter support, and we also need it to be decoupled. AI agent need to be decoupled from the AI models, and we also need to schedule the AI agents for in the right place. And for the developers and users, well, they, right now for us to use AI models, most of them are using, Python because it's easy to use. But there are other language users, for example, like Golang or people using JavaScript. And these people, we also want them to take advantage of all the AI models. So how do we do that, right? That's another pain point. And also, how we enhance the external interactions. Right now, the agents, they're bound to a particular platform. So how do we make the agents interact with each other so that so that we can make the best use of them, right? So for us, our main focus are on the agent layer and the dev and user layer. Okay, now let's introduce Sphere. So just as what I just mentioned, InfiniEdge AI is under Linux Foundation Edge, and we have multiple work streams in InfiniEdge AI. It's like a big umbrella, and we have a bunch of different work streams. And Sphere is the third work stream. And this information you should be able to see online. And there, we have website and wiki. Like if you need more information, you can just look it up. And there are other work streams cover different areas, like in the edge computing, for example, robotics, edge gateways, databases, and some other different areas. And our most recent release is 1.1. Okay, so I'll just give some brief introduction about the Sphere release 1.1, the summary. There are the data serialization, deserialization improvements. There are tool count improvements, DeepSeek integration, and test case improvement. And these are just more a lot of details. I will probably just focus on the things that people here today will be mostly interested in. And this is data serialization, deserialization. In general, we use flat buffer, which support zero copy feature, so that when we are running AI workload, we will not be able to do a lot of data copying between serialization and deserialization. And DeepSeek integration. So we integrate DeepSeek into our Sphere platform, but I mean, right now there are some limitations in the function call support in DeepSeek. We hope they can resolve this issue soon, so that we can run different AI agents on DeepSeek. Okay. Later, I'm going to show a demo, and here the demo is one agent which runs on top of Sphere. And the agent is only around 100 lines of code. You can see I just give a screenshot of the code of this agent. So you can see that if just agent listen to your input and then do something. Well, on our Sphere platform, we have different built-in tool support. Of course, we can support other kind of user-defined tool. But right now we have a bunch of like the built-in tools. For example, here's the daytime. Right-click your mouse or open the web page. Later, yeah, because right now, like my laptop is in use, so I cannot show you live demo. So instead, I have a recording. I will play the recording. Thank you for you. Yeah. Let me share the. Oh yeah, please. Okay. Let's see.
Hi guys, today we're going to show you one example agent running on top of Spear. Spear provides different kind of built-in function calls that can be used by the agent. In this case, this agent will listen to what the user said and then run some corresponding actions. What is the current date?
The current date is March 13th, 2025.
Can you help me to open Intel's homepage?
Intel's homepage has been opened successfully.
Can you help me to right-click my mouse?
The mouse has been right-clicked successfully.
Okay, so instead of these simple actions, it can also run some complete task. But this is we don't have enough time to show these actions today. So if you're interested in this, feel free to contact us, and we'll be able to show you more examples. Thank you.
Okay, thank you. This is the recording. This is the next one. Okay, now it's Roy's turn. I'm done with my demo, and here to you, Roy.
Yeah, so actually we are doing as also Tina mentioned, and thanks Tina for giving a lot more details on the integration of OPEA and Sphere. I would like to first introduce what is OPEA, since I think the people inside the InfiniEdge are not so familiar with this project. So OPEA stands for Open Platform for Enterprise AI. So its goal is to simplify the development, perfection, and adoption of Gen AI applications for enterprise. So to achieve this goal, OPEA actually provides a no. Actually, I don't have a microphone, but can you hear me clearly? I can use the microphone. Okay, is it better?
Yes.
Okay, so let me just continue to fulfill these goals. OP actually provides a list of things. First, it provides a list of microservice-based compute composing building blocks that can be leveraged to generate your GenAI workflow. And then it provides things like LLMs, embeddings, data stores, or things like ASRs or TDS. Next, OP actually provides a list of architectural blueprints. Or we can say it is a end-to-end workflow that you can leverage as a central application or a solid foundation where you can build your own application. Third, we provide a list of deployment scripts that you can leverage to deploy different kind of environment according to your use. So let me just show the next one. I also have a picture here to show the rack pipeline blueprint. It contains a lot of the components that I mentioned before, things like the embedding retrieval, ranking, or the LLMs or guardrails. So this is the one of the blueprint we have to contain all the rack stuff inside, so that people can just leverage it and use it in their own app, or just maybe do some refactoring and make their own application. I think I did a lot on what is OPEA, but I still want to show a bit on what OPEA will bring us. There are four points. The first thing is I want to emphasize more. The first thing is about easy development and deployment. So we know that the AI industry are changing fastly almost every day. We compare today, we have a new model that released like PC or something from China, right? And tomorrow we could hear that, oh, there's a new architecture already. Then that made people feel, oh wow, so many new things. How can we integrate all these changes into our own application or workflow? Then you can choose OPEA. Since our OPEA is an open source project, it like gains from the community and contributes to the community. So that with few changes or like few commands change, we can easily change your current deployment to a new model or maybe add some other microservice-based service into your workflow. And next is about the environment. So we could see that you can start from the existing environment you have. You do not need to procure totally new hardware since OPEA has support on different platforms, from client side to data center. So it supports across the hardware vendors such as Intel, AMD, or even NVIDIA. So you can choose what you have and bring it up on your own infrastructure. Then the third is about the integration. As we mentioned, it's a loosely coupled architecture. Everything is a microservice, right? So you can easily grab apart and make it into an enterprise workflow, or either make it integrated with the ecosystem. That's totally fine. And fourth is about development. Like you can have more agility on either development and deployment of AI apps. And next I want to show is something more clear, like the speed return on investment. It actually gains from all the points I mentioned before, like it's gained from the community. So you have lower operational costs, right? Then next is about the quality. We'll do some enhancement, but we'll also adopt the enhancement from the community to help you make your application more stable and maybe higher quality. Soon I want to talk about the security. So this OPEA provides people with capability that you can host your own application or AI workflow locally. So it can adapt to different kinds of environments, such as our on-premise data center, or we can use it in a private cloud or even on edge. Then what if you do have a very high security set? In OPEA, we already have some hardware keys support inside. So in that case, you can have your AI workflow totally running inside the hardware key. So that you can make your data
Close.
is, yeah. Anyone talking online?
Can you go closer to the microphone? Your voice is a little bit here, like from far away or under the tunnel.
Okay, so maybe, is it better right now?
A little bit better. Can you get even closer?
All right, seems like there's a like confliction on the voice. So this is make my voice maybe clearer online, right?
Yeah, now it's better.
Yes, but maybe I'll just become louder, okay? I can become louder as louder as I can. So I think I'm talking about the third thing, security. So I mentioned if people want security, they could put their whole AI workflow inside hardware TE, so that the hardware TE will help to make sure that your whole AI workflow is secure, even the data is in use. That's the third part. And the fourth part I want to talk about is the end-to-end use case. I mentioned we provide a list of architectural blueprints or maybe end-to-end workflows, but they are actually categorized into different types. Like the basic ones could be check Q&A. I think a very simple one, everyone is playing with. And maybe an enhanced one, the modeling model check Q&A. Then it also provides things like the generation stuff, the code generation or doc summary, they are all provided. You can leverage these reference samples, then do some refactoring and change it into like stubs for research, or maybe do some detection. They are all available inside our repo. I think I also put a QR code in the previous slide, so that if you are very much interested, go just check inside our website or inside our repo. Okay, so I think I talk a lot about the development and deployment. So every day people are struggling with the deployment side. So we want to provide something that makes you have a one click. Then you can have the microservice up and running. So here I will just show them. Oh. Okay, so we have cloned our repository. Then we get into our repository and start do the settings. First setting we are going to do is we're going to set some environment variables. Things like the pod number you want to set, and also the most important one, the LLM model ID, which is the model you actually want to deploy inside your environment. The next step, we do use this Docker Compose command. We already have the Docker Compose file ready inside our repo, so you just choose the Docker Compose and you can have the LLM microservice running, right? We could see there are two containers involved in this microservice. The first one is the inference backend. So here we use the VLM, and also there's another proxy service that you can leverage for the LLM generation. So we have these two up and running, but I also want to show you something more inside the Docker Compose file. If the demo will just get into the Docker Compose file, and you could see that even in this case, we're using the VLM as the inference backend. We can choose TGI or Llama. It depends on you. You can choose whatever we support it and set it inside the command line. Then you can bring it up quickly, just in one click. And I also have one thing to mention. So if you have a single machine, I think Docker Compose is good enough. You can just use one Docker Compose command to bring up the service. But what if you have an edge cluster? That means you have multiple machines, and maybe you want to do some scaling, you want to do resource management, but we also provide the things. We provided the Kubernetes-based Helm chart where you can still use the similar one-click things to bring up the service inside the Kubernetes. Then you can leverage the power from the Kubernetes to do scaling, to do resource management. So that's pretty much, I want to talk about OPEA, but I also want to mention what these OPEA will bring to Sphere, right? So I think most likely more options. It's quite simple to the audience. Like we are bringing people with more options on LLM models. It brings people more options on what kind of environment you want to use. It's according to you. If you have the current environment using a edge cluster, you can choose it and to find a proper hardware settings and bring up the service. And then if you want to have a complicated AI workflow, that's fine. Choose any of the AI components that's available inside OPEA and integrate into the workflow so that you can have a more complicated AI agent. And the fourth thing I think is the security. I already mentioned a lot about security, so I just skipped this part. Next, I think I will hand over to Wilson to let him tell about the actual details on what's the integration between Sphere and OPEA. Wilson, hand over to you.
Thank you. Now I'm just going to give you guys one case for Sphere and OPEA integration. And this is a joint effort between TikTok, ByteDance, and OPEA. So the teams involved are like TikTok Live Studio team, InfiniEdge AI community, OPEA team, and also like ByteDance Global Edge team. And in our scenario, what we need actually, we need an agent, like AI agent running for TikTok Live Studio. Like they are like for gameplay case, like people want to they are like gameplay online, and they so like they will use a laptop and then like the cassette to the using a different different software and make it online, right? So in this case, like when they have when they are running when they are doing it online, and then there will be people like joining, and in the room, like people some people might make some bad comments, and they in this case, the host need to at least like mute these people, right? But in this case, they cannot because they are in the playing the game. They don't have like a lot of time to do these actions. When they actually finish the actions, probably these already done. They are already gone. So it's they need to do it in time. So what they want is like TikTok Live Studio, they want to have an AI agent running. And for this AI agent, they listen to what user said, and in case if some command needs to be executed, they want to run this command without the user to to click on their interface. So in this case, they want this AI agent deployed on the edge because they don't want to deploy like the AI models on the user computer. So in this case, we have all this team collaborate together and makes this happen. Right now, this in progress, and we are very close to it. And later, I think when this is done, then we will have some, we will let everyone know. So if you're interested, please contact us, and then we'll keep you updated. Yes. Okay, so that's it, I think, for our today's talk. And thank you, everyone. And if you have, do you guys have any questions? Tina, is there any question on the your side?
I'm asking comment questions.
Here we have one question. Sorry.
About that, what kind of enterprise how to say that will OPEA, OPEA? What kind of scale? A big company or some small company, maybe education.
We want to like make it adapt to different kind of size. Even a small company, you can take leverage of the OPEA software and bring up your own AI workflow. That's fine. We do not have any limitations on or restrictions on this can be used for a small company or a big company. It's just a software, and you can leverage that whatever resource you have, right? You can have it level up, then have the applications running for using this kind of OPEA development suite or anything else. It's not limited to any size of a company.
No limit.
Yeah.
No limit.
Yeah, there are no limitations, so you can just try it on. But if you have a super large company and have a super large cluster, then maybe we need to do some enhancement to in order make sure the performance meets your need.
That's actually our plan. So for Sphere, actually we want to take advantage of the feature provided by OPEA. We want to use, at least in our case, we want to use OPEA to manage our edge clusters. So we have edge cluster, for example, a few hundred nodes in the cluster, and then inside the cluster we want it to be able to use OPEA to manage our computing resources, and then on top of that, we will deploy the AI agents. Yeah.
Many online brands in education industry, many more courses.
They want to work up their AI workflow, right?
They want to import the AI agents to their company, but they don't know how to deploy the AI agents with the lower cost. So I just see the OPEA is very convenient for them.
Yeah, maybe we can have some more discussions later on.
Okay.
Thank you. Any other questions? Tina, is there any question? If people have a question on your side?
I'm asking any questions from outside? Yeah, if not, we've reached our break. Please enjoy a brief pause before selecting between our two upcoming tracks.